Hi students, this is Ms. Tai here. In this video, we will review questions number 103 to 107 of the 2024 SHSAT Practice Exam, Form B. Grab a notebook and pencil, and let's get started. Number 103, what is the value of the expression above in decimal form? Let's go ahead and evaluate the expression. 0 to the third power is simply 0 times 0 times 0, which is equivalent to 0. 4 to the 0th power is 1, because any number raised to the 0th power is 1. 2 to the negative first power actually becomes a fraction. Anytime you have a negative exponent, simply send the exponent into the denominator, change the exponent to be a positive number, and the numerator is now a 1. So 2 to the negative first power is actually 1/2. Negative 1 to the second power is simply negative 1 times negative 1. Negative 1 times negative 1 is 1. Now we can go ahead and add the numbers. 0 plus 1 is 1, plus 1/2 is 1.5, plus 1 is 2.5. And when we convert 2.5 into a decimal, we will have 2.5. So D is the correct answer. Number 104. 4 slips of paper numbered 1, 2, 3, and 4 were placed in a bag. One slip was selected from the bag and the number recorded. Without replacement, a second slip was chosen. This process continued until no more slips remained in the bag. One part of a tree diagram representing the sample space is shown. Which number should be placed in the box to complete this part of the tree diagram? In this part of the tree diagram, the number 1 was selected, and because the problem specifically states that it's without replacement, 1 was not put back into the bag. We're left with 2, 3, and 4. If the number 2 is selected, it is now removed from the bag. So we now have 3 and 4 remaining. If the number 4 is selected, it is removed from the bag, and the number remaining in the bag would be the number 3. So G is the correct answer. Number 105. The outdoor temperature was 4.2 degrees Fahrenheit at 10 p.m. After 3.5 hours, the outdoor temperature was negative 0.7 degrees Fahrenheit. Which value best represents the average change in temperature per hour? So let's go ahead and calculate the change in temperature divided by the change in time. Anytime we are calculating the change in values, we typically want to look at the new value minus the original value. And in this case, the new temperature is negative 0.7. Then we will subtract the original temperature, which was 4.2. The problem already gives us the change in time. It tells us that 3.5 hours have passed. So that is 3.5 here in our denominator. When we go ahead and subtract, I like to use the rule that when subtracting numbers with the same sign, you will add the numbers and keep the sign. So we now have negative 4.9 divided by 3.5. Let's divide. For negative 4.9 divided by 3.5, we don't like to have a decimal in the denominator. So in order to turn this denominator into a whole number, we will multiply both the numerator and denominator by 10. This is going to cause the decimal point to move one place to the right. So now we have negative 49 divided by 35. Let's go ahead and divide. When we have negative 49 divided by 35, we know that a negative divided by a positive is negative. 35 cannot go into 4, but it can go into 49 one time. And then we're going to have a remainder. So I go ahead and add a decimal point and add a 0. The remainder when 35 goes into 49 is going to be 14. Now we have 140 divided by 35. Since I know that 35 times 2 is 70, my guess is that 35 times 4 is going to be 140. Let's double check our work. 35 times 4, we have 4 times 5 is 20. Carry the 2, 4 times 3 is 12, plus 2 is 14. So we are correct. 35 goes into 140 4 times with no remainder. Notice we have a negative sign because the temperature is actually dropping. From 10 p.m., it starts off at 4.2 degrees Fahrenheit, and then 3.5 hours later, it goes down to negative 0.7. So the average change in temperature per hour is that it's going down 1.4 degrees Fahrenheit per hour. So the correct answer is choice A. Number 106, a rectangular swimming pool of uniform depth is 20 yards long and 14 yards wide. If the water is 6 feet deep, what is the volume of water in the pool in cubic yards? Let's draw a diagram. So we can tell that this rectangular swimming pool looks like a rectangular prism. It's 20 yards long, 14 yards wide, and 6 feet deep. Because we need to figure out the total volume in cubic yards, we need to convert feet into yards. Did you know the conversion from feet to yards? We know that 3 feet equals 1 yard. So instead of 6 feet, we can change the depth to 2 yards. How did I get that, guys, right? We know that 3 feet equals 1 yard, so we can go ahead and multiply both sides of this equation by 2. 1 times 2 is 2, so we know that 6 feet equals 2 yards. Now that we have the dimensions of this rectangular prism all expressed in the form of yards, we can use our volume formula. The volume of a rectangular prism is length times width times height. So the volume is 20 times 14 times 2. Since 14 times 20 is 280, then we can multiply that by 2. We will have 560 cubic yards. So the correct answer is choice G. Number 107. A student made a list of all possible products of 2 different numbers in the set above. What fraction of the products are odd? Let's write out all of the possible pairings. We can have 3 times 4, 3 times 5, 3 times 6, and 3 times 7. We can also have 4 times 5, 4 times 6, and 4 times 7. We can have 5 times 6 and 5 times 7. And finally, we can have 6 times 7. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible products of 2 different numbers. Now let's identify which one of these products are odd. So we know that in order to get an odd product, we would need an odd number times an odd number. That's the only way we're going to end up with an odd product. So when we take a look at our possible products here, we have 3 times 5, we have 3 times 7, we have 5 times 7, and those are the only possible pairs where you're multiplying 2 odd numbers. So the fraction of products that are odd will be 3 out of 10. So B is the correct answer. If you learned something in this video, please go ahead and like, comment, share, and subscribe, and I'll see you in the next video.